Good morning. Hope everybody's doing well. We're going to go through and do a quick lesson today on circles and tangent lines to circles. I know I've mentioned this before. We're not going very far in depth with this kind of stuff. I'm just doing the very basic examples with you guys, trying to make sure you guys get the really important concepts moving forward. We're still not sure exactly what's going to happen next year, whether we're going to review this stuff at the beginning of the year or how this is all going to work. So I appreciate you guys sticking with me. Reminder, the assignments are on Pearson. If you guys come in here and you guys load your class, I'm going to get a different view of a window here, but it'll go through and you guys should have an assignment thing that comes up like this, and you guys should be able to go through here and complete the assignments. So we're going to go through a quick lesson today. It's 4 examples and a couple of definitions, so it shouldn't be too bad, okay? If you guys ever have questions, I'm still setting up the conferences. I haven't been sending out remind messages and saying, hey, there's a conference today, because I didn't know if it was necessary. Again, they're just for questions. I know I'm starting to lose some of you guys. So stick with me about 3 more weeks, okay? So we're going to go through and we're going to talk about tangent lines. So we're still talking about circles. We looked at the equations of circles. Equation was x minus h squared plus y minus k squared equals r squared, where h and k was the center. The last time we went through and we looked at arc length and sector area. So we went through and we looked at the portion of outside of circles, portions of the circumference, portion of the areas, and how to find those. And they were just proportional relationships. So it was just a proportion of the circumference or proportion to the area. Today, we're going to go through and we're going to talk about things that are called tangent lines to circles, okay? So let me show you guys what that is right now. When we have a segment that is tangent to a circle, so this has nothing to do with the trig functions that we looked at before. We're talking about a line that is tangent to something. A line that is tangent to something means it approaches it and it touches it at exactly one point. So a tangent line to a circle, if we're looking at this circle here that's centered at C, a line starts on the outside, and it's really a line segment because we're not going to have these continue forever. But a tangent line is going to come up this way. And is, I didn't do a very good job there. Let's start here and do it that way. Tangent, see again, I didn't do a very good job. That intersected twice. So a tangent line is going to come up like that, and it's going to intersect the circle at exactly one point. So if that line was to continue, and I know my line isn't straight that very well there, that's because this isn't a perfect circle. But if this line was to continue going along here, it would touch exactly at that point, this point here, which I'm going to go ahead and label B, and then it would continue on and it would never intersect the circle again. If a line comes through, and this is not a tangent line, so if a line was to come through here and go like that to A, that line's not going to be tangent to the circle. Hi, Lucy. My cat's jumping up in bed. So if that line would not be tangent to the circle because it's intersecting at more than one point. So a tangent line, when they talk about a tangent line to a circle, or they say, hey, that line's tangent to a circle, what they really mean is that line or the line segment is coming up and it's intersecting that circle at exactly one point. No more. The reason that tangent lines are important is because they have a couple of properties. So they have a couple of different properties that we can use, we can apply. These actually end up really working out well in word problems and things like that when we're trying to go through and find distances and some things like that. We're not going to look at them due to the fact that we can't really go over them together. So I want you guys to remember 2 different things about tangent circles. The first one, or tangent lines, I'm sorry. First really important thing that you guys have to remember is a tangent line is perpendicular to the radius at the point of intersection of the two. So this tangent line, this line AB right here is tangent to the circle. If I was to draw the radius right here from B to C, this line segment AB is perpendicular to the radius BC. So what does that mean? Perpendicular actually means that we get a 90-degree angle, right? So if 2 lines are perpendicular, that means they intersect to create 4 90-degree angles. Well, that just means that that's a 90-degree angle. But that means that if I go through that way, I've now created a right triangle. So we can go through, given some information, and we can figure out some things. So if you guys have a line that's tangent to a circle, and they ask you to go through and to find a length. So if you just have one tangent line like we're looking at down here, we're going to use this perpendicular, and we're going to go through and we're going to set up some right triangles and do some work there. Okay, so again, first thing, and there's only two things I'm going to want you guys to remember today. A tangent line is perpendicular to the radius at the point where they intersect, okay? So we're going to go down here and we're going to do a couple of problems. You'll see, I think there's two of them like this in your homework, okay? So first one, we've got this circle C here, and they went through, and we're going to go ahead and all of these problems, we're going to assume that lines that appear to be tangent are, okay? So I know I didn't draw these circles perfectly. My lines don't always look perfect. This one right here, this RQ actually looks like it intersects at more than one point. We're just going to go ahead and pretend that they don't, okay? So the first one, they ask us to go through and define that side BA. So they gave us this distance. They told us that CB was 9. They gave us this distance from D to A and told us that was 6. They want us to find BA. So what I want you guys to do, whatever you're trying to find there, put your variable there. From there, we need to go through and figure out what we can do. I know that AB is tangent. So if AB is a tangent line, that means that it has to be perpendicular to the radius at the point of intersection. So that has to be a right angle. If I've got a right triangle, I could use trig or I could use Pythagorean theorem to go through and to solve these. The problem right now is I don't know this entire side CA. So I need to know this whole side. I know that this part from D to A is 6. How can I go through and figure out what this part is, the CD, in order to figure out this whole length is? You're right, 9. So we know that's a radius. So we know every radius has to be equal. So I know that's 9. So if we go through and add those two together, I get 15 there, right? So now what I've really done is I've got a right triangle here. I know this side is 9. I know that side's 15. I know that side's x. That looks like Pythagorean theorem to me. Legs squared, so a squared plus b squared equals c squared. Remember, c is always your hypotenuse. So we want 9 squared plus x squared equals 15 squared. 9 squared is 81. X squared, 15 squared is 225. Remember, if your hypotenuse isn't the side you're trying to solve for, you're going to have to do some subtraction here. So subtract 81 from both sides. We've got that x squared is 144. And then you guys all remember from earlier this year, to get rid of that squared, we take a square root, and we're going to get that x is equal to 12. So that side length BA is actually equal to 12. We're going to be using Pythagorean theorem here, guys. So right triangles, I want you guys to Pythagorean theorem or trig. You could have gone through with the 9 and the 15 and gone through and solved for an angle. You could use inverse trig to go through and found the measure of A or the measure of C, and then gone through and use regular trig to go through and solve for BA. That's a little bit too much work. So if you guys can use Pythagorean theorem, I want you to use it, okay? Let's look at another one. So the second one, and here I'm going to write off to the side, but the second one, we've got the circle P. Again, we're going to pretend that my line's perfect here and that QR is tangent to the circle. Then they gave us some things here. They told us that QR was 26. They told us that SR was 16, and they want us to find the radius. So I'm going to go ahead and I'm going to label this for you guys. QR was 26, so QR is this bottom side right here. So let's put our 26 there. They told us that SR was 16. So they gave us this length outside the circle again, but last time they gave us this distance. Now they want us to find the radius, so I'm going to put an X there. The other thing I'm going to do for a hint for you guys is I'm going to put an X there. Now go ahead and pause. We're going to do this one the same way as the last one. Go ahead and pause the video, see if you guys can go through and work that problem out, okay? It's going to look a little different than the last one because of the variables in here, but see what you get. And then come back and check your solution, sorry. All right, so we're going to set this one up the same way. So we're going to set it up as leg squared plus leg squared equals hypotenuse squared. Remember, hypotenuse is the side across from the right angle. So it's going to be that side right there. If I want to get this entire side length, this side PR here, I need to add this part PS and I need to add that part SR. That's a segment addition postulate. It says if you got a whole segment, you break it into two parts, you add the two parts together, it equals the whole thing. You guys remember earlier this year, I broke the ruler and showed you guys that. So this entire side here is going to be x plus 16. This side is x, this side is 26. So I like to redraw the triangles if I can. 26, x plus 16, and x. We've got extra variables in there, but it shouldn't be the end of the world, okay? So we're going to set this one up the same way we did the last one. So it's a squared plus b squared equals c squared. So I want x squared plus 26 squared equals, don't forget when you guys have a variable in there, that's a quantity. So that's x plus 16 squared that way, okay? So we're going to have to go through and we're going to have to multiply that out, but it's the same idea as the last one. We're still using Pythagorean theorem. We're still using the same ideas. So as we continue to work on the left, I've got x squared, 26 squared, $676. That sounds right. And when we go through and we multiply out that x plus 16, if you guys remember earlier this year, we went through and we used the distributive property twice. And we ended up with x squared plus 16x plus 16x. 16 times 16 is 162.56. So that ends up being x squared plus 32x plus 256. Again, all I did there, guys, we used FOIL, we used the distributive property, however you guys want to think about that. So I'm going to erase my 26 squared here so I don't run into myself really quick. And then we're going to write this as x squared plus 32x plus 256. So we're going to have to go through and solve that. Not the end of the world. I know you guys are going to see those x squareds and you guys are going to think that we're going to have to factor or something. You guys are going to freak out. We don't. The x squareds are actually going to go away here. So I'm just rewriting this so I've got some more room up here. And I'm going to erase it down there. So if we get all the x squareds on one side, what you guys are going to notice is they're going to go away. So that's going to become really nice. Now I've got 676 on this side equals the 32x plus 256. Let me fix my 2 there. Subtract that 256. 520 equals 32x. 420, sorry. I think if I make any subtraction mistakes, you guys can catch me and point them out later, okay? So that 420 is 32x. If you guys divide those out, again, I don't have a calculator sitting right next to me and my phone's downstairs. 13, I've got 96 with 3 left over. So I've got 13 point something. So I'm going to go ahead and say that if I've got a remainder of, that was 96, 100, so the remainder was 13.1 something. So they asked us to go through and define that radius. We end up having to do a little bit more work than we did in the last one. You guys look at the first problem because we've got whole numbers and they didn't make us solve for something with a variable in here. It wasn't quite as bad. The second one, we had the variable in this part, so we ended up with 1 on both sides. Still wasn't the end of the world. We just had to go through and use the distributive property to multiply out x plus 16 squared. And then because we got a decimal here, it ended up looking a little bit nastier, but it's really not that bad. X is 13.1. Last one with this same property, and you guys will probably see one like this in your homework. Same idea as the last one. Go through, write it down, try to work it out, see what the answer is, and then come back and check the video, okay? So here they ask us to find, and I'm writing all over so you guys can't see it, ask us to find the measure of angle BAD. So again, our line AB is tangent to the circle. We've got AC up there. We've got CB. This time they gave us angle measures. They didn't give us side lengths. We know that this is a right angle. They asked us to find the measure of BAD. So you guys are trying to find the measure of that angle. Remember, you can't just say it's x plus 6. So to go through and solve this one, we know this is a right angle, right? So I know that one has to be 90. You guys also know something about the 3 angles in a triangle. 3 angles in a triangle have to add to 180 degrees. So this first angle plus the second angle plus the third angle has to equal 180. You guys could also go through really and say that the first one plus the second one has to equal 90 if you guys just wanted to get rid of the 90 degree angle, but I want to keep them all there so you guys know what's going on. So triangle sum theorem, guys, that's all we're using. And again, we're applying this fact that the tangent has to be perpendicular to the radius, so we get a right triangle. Right triangles are powerful because if we can set those up, we can go through and find things. So let's combine like terms here. 2x and x gives me 3x. 90 plus 6 is 96. 96 minus 4 is 92. So I've got 3x plus 92 equals 180. Subtract 92. And I'm trying to start to think about answers. And we get 3x equals 88. Looks like we're getting lots of decimals. No, that'll come out to no, that won't be a whole number. I wonder if I wrote some of these down wrong earlier. That's no big deal. Decimals are okay. So divide both sides by 3. And you guys are going to go ahead and get, let's see, 2, 6, 2, 8, 9, 27, 1, 0. So 29.3 repeating. So we found out that x was 29.3 repeating. They didn't ask me to find x, though. They asked me to find the measure of angle BAD. So BAD was this one, 29.3 plus 6 is 35.3 degrees. And all I did was plugged in that 29.3. So if you guys have a line that is tangent to a circle, you know it's got to be perpendicular to the radius. The other thing that's going to come up in your guys' homework assignment, and it looks a little bit different than the problem I'm going to do with you guys right now, but it's the same idea. The problem we have doesn't have variables in it, but it requires you to work with a bunch of different tangent lines. And I've got writing all over this now, so avoid all the pink. But if two lines are tangent to a circle from the same exterior point, external point, exterior, same difference there, the lines are congruent. So you guys haven't seen that symbol in a while. That means they're congruent, so they have to be the same. Really quickly, without boring you guys, wanted to say why. And we're going to kind of think about this diagram down here where you guys have two lines that are tangent to a circle from the same point. If you guys were to think about this and think back to congruent triangles, because I know you guys love those so much. If I had two lines that both go like that, and then that goes there, and that goes there, and that goes there, I know that both of these are a radius. I know that both of these are right angles because they're tangent. I know they don't look like it, but that's because I drew it wrong. I also know this side is reflexive. So what we really have there is we've got two right triangles. One of them looks like that. And I've got congruent, and I've got the triangle on the bottom that looks like that. And I've got congruent. So by HL, those triangles have to be congruent. Hypotenuse leg, which means CPCTC tells me all their parts have to be the same, and those two have to be the same. Again, in class, we would go through and we would spend a lot more time about that, but that's another reason that we spent so much time on congruent triangles earlier this year, is because we use congruent triangles to prove a lot of things about other different shapes and things like that. So there's the reason why they're congruent. Let's go through and let's look at an example. Again, the one in the homework is going to look a little bit different. I want you guys, actually, it's going to look a lot a bit different. I'll show you a picture in a second of what it's going to look like and give you an idea. But here, let's just say they want us to go through and to find x. So we've got that circle. I was lazy, so I didn't even mark it with a center of C. We have an external point P, and we have two lines that are tangent to that circle. We've got, this one has a length of 5x minus 11. This one has a length of 3x plus 3. They want us to find x. So what do we know about those two segments? What do we know about this segment and that one? We know they're congruent because they're both tangent. So if they're both congruent because they're tangent, then that means that they have to be the same length. If they're the same length, that means their lengths are equal. So we can go through and do 5x minus 11 equals 3x plus 3. Add 11 to both sides. The 5x is equal to 3x plus 14. Subtract your 3x from both sides. I've got my 2x is 14. Hopefully you guys can't hear my wife yelling at my son downstairs because he's not getting all his stuff done. And we'll get x is equal to 7. Important part, guys, and I feel like I went through that really, really quick. Usually by the time we get to the point in this video, I'm usually trying to kind of hustle to keep it short and keep your guys' attention. Important thing is that when you guys have two lines that are tangent to a circle from the same point, that means that those lines are the same length. The problem in the homework has something like this, and it's got a shape. Actually, you know what? Let me jump over here. I'm not going to do it for you guys, but we can talk about it really quick. So we're in 10-2. I know only one. It looks like only one of you guys finished the 10-1 stuff. From this is fourth period, so there's only one. There's only 19 of you guys in here, but try to get it done. Remember, I'll give you guys the grade bump. So let's see. Can I want to preview. There we go. Also, if you guys want additional problems in here, there were some other ones. That wasn't supposed to happen, so let's try this again. Oh gosh, is the website not working now? We'll tell you what, since I don't want to keep the video going really, really long, this is a perfect reason for us to have a conference and you guys to show up tomorrow. So Tuesday the 5th is today. Happy Cinco de Mayo. Wednesday, tomorrow, we will do a conference at 11. If you guys have any questions, show up. That includes the homework problem that I'm assuming some of you guys are going to be confused about because I can't bring it up. Again, I know I haven't been posting a ton of stuff. I don't want to overwork you guys. I'm trying to keep the assignments short so you guys have incentive to keep going. It seems like I'm losing a lot of you guys. So do your best to stick with me. I miss you guys. We got 3 more weeks and we'll be done. All right. Talk to you guys later.